Part A, factorise completely, x cubed minus 4x. So let's start off by factorising x outside, which will leave me with x squared minus 4 on the inside. I can then factorise a little bit more because I can use the difference of two squares to factorise x squared minus 4. It will be x minus 2, x plus 2. That is now factorised fully. Part B, sketch the curve with the equation y equals x cubed minus 4x, showing the coordinates of the points where the curve crosses the x-axis. So I know it has a root at 0, it has a root at plus 2, and I know it has a root at minus 2. I also know that it is a positive x cubed rather than a negative, so it's going to start by going up rather than down. So it's going to look something like that. Part C. On a separate diagram, sketch the curve with the equation y equals x minus 1 cubed minus 4 lots of x minus 1, showing the coordinates of the points where the curve crosses the x-axis. Well, this is part C of the question. I'm thinking that this has probably got something to do with what I've just done. And if we look carefully and compare it to what we've just done, I just drew x cubed minus 4x. And the only difference here, instead of an x cubed, we've got an x minus 1 cubed. Instead of a 4x, we've got a 4 lots of x minus 1. So this is identical except with the x minus 1 instead of the x. It's like me drawing this. So all I'm doing here is I'm going to add 1 to all of the x coordinates. The x minus 1 on the inside here means it affects the x coordinates only. I do the opposite, so I'm going to add 1 to all of the x coordinates. So the whole graph is going to shift 1 square to the left. So whereas previously it had roots at minus 2, it's now going to have a root at minus 1. Where previously it had a root at 0, it's now going to have a root at 1. And previously the third root was at 2, it's now going to have a root at 3. The y coordinates are unaffected, so it's still going to look like this. Just shifted 1 square to the left, to the right, sorry. There we go.